All right, Algebra 2, we're going to go ahead and start Unit 11. Unit 11 and Unit 12, those are the last two units that we're going to go through this semester. And those are all going to be on trig. So we're going to look at all these various parts of trig and triangles and angles and graphing and solving trig equations. So when we have angles, typically we use a symbol to identify an angle, and this is called the angle theta. All right, so this is a Greek letter. We talked about a Greek letter before that was sigma. That was that E. So this is the symbol theta, and anytime you see it, it's used to identify an angle. And so we have graphs of angles that we're going to be creating, and we typically graph an angle on an XY axis, and an angle is made up of two rays that come together at a vertex point. And so we're going to put one of the rays, it's called the initial side, on the positive x-axis, and it's always going to stay there. But the terminal side, the other ray, is going to rotate. Now it can rotate in the clockwise direction or counterclockwise direction, depending on what kind of an angle we want to create. And that angle is called the angle of rotation. And the vertex point where the two rays come together will always be at 0, 0, so the origin. So some angles that we want to start to identify and start to memorize where they're located. So on an XY axis, this would be 0 degrees right here. And then if we go in the counterclockwise direction, this would be 90. 180 degrees is going to be directly across from 0. And then 270 would be across from 90. And then if we do one complete rotation, that's going to be 360 degrees, which is going to be the exact same spot where 0 degrees is. All right, so we can create positive and negative angles. So positive angles are going to go in the counterclockwise direction. So we need to change this to counterclockwise. All right, so for example, if we want to create a 60-degree angle, we're going to put the initial side on the positive x-axis side. The vertex point is going to be at 0, 0. And so if we want to do a 60-degree angle, well, we know where 90 is. 90 is up here. So we know 60 is less than 90. And so it's going to be somewhere about right there. All right, and then we do what's called an angle of rotation to show which direction we went. And so since we're going in the counterclockwise direction to show a positive angle, this is showing a positive 60 degrees. All right, so it shows that that terminal side, the red side, was at 0 and it rotated in the counterclockwise 60 degrees. All right, so negative angles are going to go actually in the clockwise direction. So cross that out. So clockwise direction. And so for example, if we want to do a negative 45 degrees, again, we'll start, the initial side is on the positive x-axis side. We have our vertex point at 0, 0. And then if we want to go in the negative 45 degrees, well, if we go in the negative side clockwise direction, negative 90 degrees would be down here. So if we want to go negative 45, it's going to be halfway to where negative 90 degrees would be. So that's going to be about right here. And then we want to, again, show that angle of rotation to show which side or which direction we rotated. And so that's going to be negative 45 degrees. So we want to remember the quadrants. Now the quadrants are never going to change. They're always going to stay in the same fixed positions. So again, we have our 0 degrees, our 90. This is just all going in the positive direction real quick. All right, and then 360 is one full rotation. Our quadrants are labeled quadrant 1, then quadrant 2 in the clockwise direction, quadrant 3, and then quadrant 4. Right. Typically we use Roman numerals. So we are going in the counterclockwise direction, and we always go in that direction to identify quadrants. So you'll never go in the clockwise direction to change the numbering for the quadrant. So it's always 1 in the upper right, and then 2 in the upper left, and then 3, and then 4. And again, it doesn't matter if you're talking about a positive angle or a negative angle, the quadrants will always stay. All right, so let's practice graphing each of these. All right, in their standard position, so positive 140 degrees. So again, always start with that initial side on the positive x-axis. 140 degrees is going to be in between 90 degrees and 180, so that's in quadrant 2. And so 140 degrees, it's going to be somewhere around there. Again, we want to put our angle of rotation in, and so that would be about 140 degrees. Negative 120. Okay, again, our initial side, positive x-axis. Negative 120 is somewhere between negative 90 and negative 180. All right, so negative 120 is going to be in quadrant 3. Okay, so more than negative 190. So it's probably about right here. Again, we want to do our angle of rotation in the negative direction. 300 degrees. All right, so again, there's our initial side. 300 degrees is going to be more than 270, and so, but less than 360. So 300 degrees is probably about right there. Again, our angle of rotation, we want to show that in the counterclockwise direction, that we went in the positive direction. So that's about 300 degrees. All right, coterminal angles. Angles that share the same ending side or the terminal side. So they start at the same place, but their ending side will be the same, but the angle is going to be different. All right, so you'll see it when we talk about this. All right, so let's say I want to graph a 120 degree angle. Right, so that's where it starts, and then 120, again, it's more than 90. So 120 is about right there. Okay, and again, we're going in the counterclockwise, counterclockwise direction, positive 120. So if I want to create, let's say I want to create another angle, and it starts and ends at the same place, but the angle measure is different. So it's not 120 degrees, but the angle looks the same as far as where the two sides start and end. So one way that we can do this is we can go in this direction right here. Right? So if I go in the negative direction or the clockwise direction, the two sides of the angle would start and end at the same place, but their angle measures are going to be different. So if I start with a positive 120 degrees and let's say I want to go in the negative direction, this angle right here is actually going to be negative 240 degrees. All right, so how do I know it's negative 240 degrees? Well, if I take a full rotation of negative 360 degrees, and if I add on the 120 degree angle that they gave me, I'm going to get negative 240 degrees. All right, so we say negative 240 is coterminal with positive 120. Now another angle I can create, now there's an infinite number of angles that are going to be coterminal to 120 degrees, but another one I could create is this one right here. So I do this spiral. All right, so this angle, this green one, is if I took 360 degrees and add on the 120, I'm going to get 480 degrees in the positive direction. All right, so that would be a positive 480 degree angle. Again, it starts and ends at the same place as 120, but the angle measures are different. So we say 480, negative 240, and 120 are all coterminal to each other because they start and end at the same place, but their angle measures are all different. So if we want to find a coterminal angle to another angle, all we're going to do is add or subtract 360 degrees. And you could do this as many times as you want. You could add 360, you could add 360, add 360, or subtract 360 multiple times, and you'll continue to get coterminal angles. So let's say we want to find two coterminal angles. We want one of them to be positive and one of them to be negative for each of the following angles. All right, so given 60 degrees, what we're going to do is add and subtract 360. All right, so we take 60 degrees, we're going to add 360, and we take 60 degrees and subtract 360. All right, so you can use your calculators to do this. 60 plus 360 is going to be 420 degrees. And 60 minus 360 is negative 300 degrees. So we say positive 420 and negative 300 degrees are both coterminal to 60 degrees. So all three of those angles are coterminal to each other. They start and end at the same place, but their measures are different. All right, so let's do the next one, 210. All right, so starting with 210, we're going to add 360, and we're going to subtract 360. All right, so 210 plus 360, that's going to be 570. And then 210 minus 360, it's a negative 150. All right, so starting with 390, can add 360. Then starting with 390, we can subtract 360. All right, so 390 plus 360 is at 750, I believe. And try to always put this little degree symbol when you're talking about degrees. Don't just put 750. All right, and then 390 minus 360, that's going to be positive 30. But the question says find one positive and one negative. Well, we haven't found a negative. So to find a negative one, we can start with 30 and subtract off another 360. All right, so we can do this as many times as we need to until we find an angle that is positive or negative, depending on what we need. All right, so 30 degrees minus 360 is going to get us negative 330. All right, so if we were answering this question, find one positive, one negative, you could give the 750, you could give the 30, or for the positive ones, all right, so you can give either one of those for positive, and then for the negative, we could use the negative 330. So you can see there's multiple positive ones that we found, but you only have to list one of them. All right, negative 300. All right, so starting with negative 300 degrees, we can add 360 and then subtract 360. All right, so negative 300 plus 360, that's going to be positive 60, so that's a positive one we can give. All right, and then negative 300 minus 360, that's negative 660. All right, and there's a negative. All right, number 8, negative 20 degrees. Okay, again, we'll add 360, subtract 360. That's positive 340, negative 380. One positive, one negative. All right, and then positive 25. So 385, and then 25 minus 360, negative 335. All right, number 10, find a coterminal angle where the angle has to be between 0 degrees and 360 degrees. All right, so what this is talking about, because it has to be between 0 and 360, it has to be a positive angle. All right, and so they want us to find only the positive angle that's between the 0 and 360. So starting at negative 120, we know that we're going to make it positive, we're going to have to add 360 to it. All right, so starting with negative 120, we can add 360, and that's going to get us positive 240 All right, so 240 is between 0 and 360, so that would be the angle that they want us to list. All right, B, 400 degrees. Well, 400 degrees is not between 0 and 360. It's too big, so to make it smaller, we're going to subtract 360. All right, so that would be 40 degrees. Starting with 790. Well, 790 is bigger than 360, so we're going to subtract 360 to make it smaller. So that's 430 degrees. But 430 degrees is still too big, so we're going to subtract off another 360. That's going to get us 70 degrees. All right, so 70 degrees is between 0 and 360. So again, you can do this as many times you need to as far as adding or subtracting 360. All right, so we're going to look at a new angle called radians. All right, so radians is just another way to identify an angle. And so as you get further in trig, we kind of start to move away from the degrees and work with radians instead. Because a lot of formulas in trig and higher math use radians instead. All right, so 1 radian is created when you take the radius of the circle, all right? And so you take the radius and you draw in 2 radii, and then you kind of think of a piece of string. If you were to take a piece of string that's the length of the radius, and you wrap it around the edge of a circle that's the exact same, you get all 3 measures to be the exact same length. All right, so this edge of the circle is exactly the same as the radius of the circle, and it creates like this pizza pie slice. All right, so all 3 of those measures are exactly the same, and the angle that's created is called 1 radian. All right, and so if you take the radian, and you can kind of see, if you were to guesstimate what that measure is in degrees. I mean, it looks similar to about 60 degrees, right? And so it's about 57.3, so it's about 57 degrees actually. All right. So 1 radian has a measure of about 57 degrees. So the way that we get this radian, it comes from, you can think of the circumference of a circle. So the measure or the formula for circumference of a circle is 2 times pi times the radius. And if we let the radius be 1 unit in length, then the circumference, which is the measure of the outside of the circle, is 2 pi, because 2 pi times 1 would be 2 pi. All right, and so 2 pi is 1 measure all the way around the circle. But 360 degrees is also 1 measure all the way around the circle. All right, and so we have a relationship between the degrees of a circle and their radians measure. So 360 degrees is 1 rotation of the circle, which is also 2 pi for the circumference. So 360 degrees is the same as 2 pi radians, which is 1 rotation around the circle. Now let's say we take that 360 degrees and cut it in half. We get 180 degrees. Well, that means we can cut the 1 rotation in half and get a half a rotation. And we can cut 2 pi in half to get 1 pi radian. All right. So now we have this relationship. A half a rotation is 180 degrees, which is also pi radians, 1 pi radian. If we took that 180 degrees and cut that in half, then we get 90 degrees. Well, 90 degrees is 1/4 or a quarter of a rotation. Okay, and in radians, it's pi over 2, a half a pi. Okay, so when we are talking about radians, we don't actually have to put a symbol. We could just say 2 pi or pi over 2, and we don't have to actually write the word radians because it's automatically understood that we're talking about radians. If we're talking about degrees, then you have to make sure that you put that little degree symbol because there's a difference between 360 and 360 degrees. 360 without any symbol means 360 radians. All right. All right. So if we want to convert degrees measure into radian measure, we're going to multiply it by this little fraction, and that'll convert from one to the other. So you can see from this chart, 360 degrees, we could multiply it by something and get the number of radians, or we have radians and we want to make it into degrees. All right, and so if we want to convert from degrees to radians, what we're going to do is multiply by pi over 180 degrees. Okay, so multiply it by pi over 180. And so what we want to think of is we want to cross out those degrees. So if we have 40 degrees, we want to convert it into radians. What we're going to do is multiply it by pi over 180 degrees. And 40 degrees, again, is just 40 degrees over 1. And so these degrees cross out. All right. And so if we multiply fractions, we can multiply straight across. So that's 40 pi over 180. All right. Now we could simplify this fraction. And, you have calculators that will simplify fractions for you. Just use your ABC key, and typically it'll do it for you. So this is going to be 2 pi over 9. So that's 2 pi over 9 radians. If you get a mixed fraction on your calculator, just convert it to improper. Typically we use improper fractions rather than mixed fractions. All right, so 270 degrees. In radians, again, we're going to multiply by pi over 180. All right, again, those degrees symbol cross out, multiplying across 270 pi over 180. Okay, again, you're going to simplify this fraction down. So that's going to be 3 over 2 pi, or 3 pi over 2. All right, so typically we write it like that instead of 3 halves pi. All right, negative 85 degrees. All right, again, we'll multiply by pi over 180 degrees. That's going to be 85 pi over negative 85 pi over 180. Again, we want to simplify our fraction down. So that's 17 pi over 36, that's negative. So it's negative 17 pi over 36 radians. So again, when we're talking about radians, we don't have to put the symbol. All right, now if we want to convert from radians into degrees, we're just going to multiply it by the reciprocal of what we just did. All right, so we're going to multiply by 180 degrees over pi. All right, so if you ever get stuck on what you should multiply, it's either pi over 180 or 180 over pi. What you want to think of is when you cross cancel, either the pi's have to cancel out if you have a pi in the numerator, or the degree symbols have to cross out if you have a degree to start with. All right, so here we want to multiply by 180 over pi because we're trying to cross the pi's out. Okay, and we want to keep the degree symbol. All right, so the pi's cancel. Again, this is 180 degrees over 6 when you multiply across, and then if you simplify that, that's 30 degrees. So 30 degrees is the same as pi over 6, or 1/6 of a pi. All right, negative 5 pi over 3, again, we'll multiply by 180 degrees over pi. So the pi's cancel. Here I could cross cancel. Again, you could just multiply across, but I know that 3 can go into 180 60 times, and then negative 5 times 60 is negative 300 degrees. 3 pi over 4, Okay, again, multiply it by 180 degrees over pi, so we can cancel the pi's out. All right, so multiplying 3 times 180, and then we're going to divide that answer by 4. It's going to give us 135 degrees. 135 degree angle is the same as 3 pi over 4 radians. All right, so let's graph given radians. All right, so they give us this 3 pi over 4 radians, and they want us to graph it. Well, a lot of times when we're graphing, it's easier to graph in degrees. And so let's convert 3 pi over 4 into degrees. All right, so to convert it, we're going to multiply it by 180 degrees over pi. Again, we're trying to cancel those pi's out, so that's why we want pi in the denominator. All right, so again, this is just 3 times 180. I think we just did this one. Divided by 4. So it's 135 degree angle in degrees. So let's graph 135 degrees. Okay, so we have our initial side. And then 135 is between 90 and 180, so that's going to be in quadrant 2. And so we have to put our angle of rotation to show we went in the positive direction. So that's 135 degrees, which is 3 pi over 4 in radians. All right, negative 11 pi over 6. Again, let's just convert it into degrees. So we're going to multiply it by 180 degrees over pi again. So let's cancel those pi's out. Let's see, 6 can go in 180 30 times. And negative 11 times 30, that's negative 330 degrees. So we're going to graph a negative 330 degrees, which is the same as negative 11 pi over 6. So again, we start at the initial side. Negative 330 is almost one complete rotation, negative 360 degrees. All right, so it's going to fall right about there, but on the negative rotation side, it'll look like that. All right, coterminal angles, again, with radians, they work the same as with degrees. 2 pi over 3, if you had to graph 2 pi over 3, again, multiply it by 180 to find the degrees. Okay, the pi's cancel. 3 can go into 180 60 times. 2 times 60 is 120 degrees. All right, so if we graphed 120 degrees, it's in quadrant 2 here. It would look like this. Okay, so that's 2 pi over 3. And then again, if we want to find a coterminal angle, we can go in the negative direction side. That'll get us a negative angle. And then we could go in the positive direction side, more than one rotation. So we do these spirals to show more than one rotation. Right. And so to find coterminal angles given radians, you can convert to degrees and then do what we did with degrees, add and subtract 360. But it's just so you don't have to convert every single time, you can work with radians, and all you have to do is add or subtract what one full rotation is in degree or in radians, which is 2 pi. All right, so instead of adding and subtracting 360, we're going to add and subtract 2 pi because 2 pi is one rotation or a revolution in radians. Just like 360 degrees is one full rotation in degrees. All right, so let's find 2 coterminal angles, one positive, one negative, given radians. So we're going to work with radians. So anytime they give you radians, we want to give our answers in radians. So pi over 3, we're going to add 2 pi, and then we're going to take pi over 3 and subtract 2 pi. So how do we do this with fractions? Well, we need to find a common denominator. And so the common denominator is 3. And so we're going to multiply 2 pi by 3 over 3. All right. So now we have pi over 3 plus 6 pi over 3. And with fractions, we keep the denominator the same and add or subtract the numerators. So 1 pi plus 6 pi is 7 pi. So if 7 pi over 3 is a positive angle that's coterminal to pi over 3. Again, if we want to subtract, we need a common denominator. So again, we multiply by 3 over 3. And so we have pi over 3 minus 6 pi over 3. Denominators are the same. So pi minus 6 pi is negative 5 pi. Negative 5 pi over 3. That would be the negative angle. All right, so all three of those, pi over 3, 7 pi over 3, and negative 5 pi over 3 are all coterminal to each other. They all start and end at the same place, but their measures are different. All right, so 2 pi over 3. So one way that you can do this to kind of shorten this up a little bit so you don't have to do all this writing every time because the denominators are going to be different. Just do this adding and subtracting, plus or minus 2 pi over 1. All right, so you'll see this will shorten it up a little bit as far as all the work. So again, we need a common denominator. Again, it's 3 over 3. So we have 2 pi over 3 plus or minus 6 pi over 3. All right, so if we add first, 2 pi over 3 plus 6 pi over 3 is 8 pi over 3. And then if we subtract, 2 pi over 3 minus 6 pi over 3 is negative 4 pi over 3. So there's a positive and a negative. So it kind of shortens it up a little bit as far as the writing goes. You can do that same thing for the degrees. Add or subtract 360. So you can just use that symbol. Just remember you're adding and subtracting to find the angles. All right, 7 pi over 6. We're going to add and subtract 2 pi again over 1. Our common denominator is 6, so we're going to multiply by 6 over 6. So now we have 7 pi over 6 plus or minus 12 pi over 6. All right, so we can add first. That's 19 pi over 6. Subtract 7 pi over 6 minus 12 pi over 6 is negative 5 pi over 6. And then last one, number 22, starting with negative 9 pi over 4. Again, we're going to add and subtract 2 pi over 1. Our common denominator is 4 this time, so multiplying by 4 over 4. It's going to get us negative 9 pi over 4 plus or minus 8 pi over 4. Okay. So doing the plus first, negative 9 pi over 4 plus 8 pi over 4 is negative pi over 4. Okay, and then subtracting, that's going to get us negative 17 pi over 4. Now we have two negatives, but we haven't found a positive one yet. All right, so let's take the smaller one, negative pi over 4. Let's add on another 2 pi, or 8 pi over 4. Okay, again, that's just another 2 pi, 1 revolution. So if we add on another 8 pi, that should make it positive, and it does, 7 pi over 4. All right, so here's a positive one, and then you could give either of those for the negative. It wouldn't matter as long as you give one of the negatives. All right, and that should be it.